earlier yesterday. Okay, guys, this is the last steps of homework 7-2. We went through the first so many yesterday. Let's end these questions right here. Multiples of 3, so we'll do 21, 24, 27, 30, 33. We're also going to discuss 34. Okay, so it says to divide and simplify, up right here, simplify. Assume all variables are positive. All right, so starting with number 18. Excuse me, not 18, 21. 21, right there. It is the square root of 18k to the 6. Does 18 have a square root, anybody? It actually doesn't. Does a factor of 18. A factor does. Help me out. Which? So we're going to take 18 and think of it as 9 times 2. So what comes out of the square root sign? What number? What stays in? So we are going to say that the square root of k to the 6 is k to the third, right? That is because k to the third times k to the third, that is the root, the square root, something that can be multiplied times itself, can make k to the 6. So yes, that is our answer for 21. 23, not 23, 24 I meant to say, is the fourth root of 256, s to the 7th, t to the 12th. All right, turn on your thinking brain here. Fourth root, I think 256 actually has a fourth root. If you're not sure, you can take your calculator and it'll give you the fourth root. You can do 256 raised to the 1/4, or actually do the fourth root. There is a button that allows you to do fourth roots. Thank you. 4. Now I'm going to assume we might end up with something inside our radical sign still. Dustin, does s to the 7th have a fourth root? No, it doesn't. Do you have any way of factoring s to the 7th to find a way to get a fourth root out of it? I'll give you a hint. There is a way of factoring it to find, like right here where we could split up 18 to make 9 and 2. We can split up s to the 7th so that one of its factors has a fourth root. Yes, sir. That's, if I take 3 of those s's over here, it leaves that, and that is the only number below 7 that is divisible by 4. See that? So Easton, what would I write? 4s to what power? Not quite. 4s. So we're trying to figure out what is the fourth root of s to the 4th? S to the first power? Yes. Listen, we would say that s times s times s times s is s to the 4th. So the fourth root of s to the 4th is s. What would be the s staying in here? S to the what? S to the third. All right. James, the t, does it have a fourth root? What is it? Very good. T to the third times t to the third times t to the third times t to the third would be t to the 12th. What do y'all feel about that one? All right, be ready to answer. I'm calling somebody different this next time. 27 is the fourth root of 625, u to the 5th, b to the 8th. Okay, Benjamin, does 625 have a fourth root? What is it? Oh, thank you. I'm going to assume, I think, there are some things that might end up still in the radical. Zane, does u to the fifth have a fourth root? No, it doesn't. Is there any factor of u to the fifth that we can use? Yes. We'll take one of the u's off, and we find a number below 5 that is divisible by 4. So Cheyenne, this u out here will be u to the what? U to the first. Understood one? All right, what about the u that stayed in? U to the first as well. It's that one right there. Andrew, the v to the eighth, does it have a fourth root? V squared? Will there be any v left inside? No. All right. Now let's go to 30. 30. On this one it says divide and simplify, assume that all variables are positive. So when you look at this radical, it's the fourth root of 243 k to the third over 3 k to the seventh. This tells me, the instructions helps me think this might be a time that I could actually divide the radicands first. Let's try that. All right. This is the fourth root of 243 k to the third over 3 k to the seventh. If I rewrite that, Dustin, as the fourth root of these things divided, let's look at just the numbers first. 243 over 3. Any ideas what that is? Need some help in the room? Everybody should be doing it. Come on, everybody playing along. What is it, guys? 81. So I can put that in the numerator. 243 divided by 3 is 81. That's nice to know. What about the k's? Just forget the numbers are there. How would I handle these k's? You can subtract. So what would we have? K to the what? -4. And we don't want to write it as negative, so where should I leave it? Bottom. Another way of thinking of this, students, is you have k times k times k in the numerator, right there. K, 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 K. You have 7 k's in the denominator. Anytime you have common variables with these exponents, this is how I see it. Watch what I do right here. I just cancel these out. You have 3 on top and 3 on bottom that can be simplified out, leaving, like you said, k to the fourth can be written in the denominator. So dividing was possible. Earlier in this worksheet, we talked about this yesterday. Right here, we couldn't divide to start, so we just rationalized our denominator. Remember that yesterday? So when dividing wasn't possible. This one, dividing helped me a little bit. Now I ask myself, does k to the fourth have a fourth root? So guess what? I don't have to rationalize my denominator because it's simplified out with no radical on its own. 81, what's its fourth root? 3, thank you. 81 to the 1/4, or the fourth root is 3. So look at there. This radical expression simplified at just 3 over k. But it took a little dividing to make it easier to start. Okay, 33 is similar. I want you to look closely at 33, see if you can. It is the square root of 162a over 6a to the third. Try that on your own paper. I know some of you have already. If you haven't, take what we just did on the problem above it, see if you can apply it to this one. It's very similar. Maybe you can come up with a solution. What's your numerator going to be? 27. What's your denominator? A squared. Y'all agree with that? That's just simplifying the radicand. The number inside the radical can be simplified through division or simplifying. Can you simplify? What about the denominator? Do I need to rationalize it, or does the radical sign go away? It goes away. What is it? What would be the square root of a squared? What's your numerator? Which can be simplified. 3. Oh, very good, Easton. 3 roots of 3. Because 27 is 9 times 3. Good job. Way to show off some math skill right there, students. Okay, that leaves us 34. 34, take the volume of a sphere of a radius. The volume of a sphere of a radius r is this equation. So if you happen to know the radius of a sphere, you would know its volume. I think this is really kind of interesting. We're gonna look at this. Just a second. I got a nickel that we gotta kind of help me understand this too. Take this box right here. On the screen, we have these boxes. I want you right now to predict if I was to put 1-inch cubes into this box. That'd be its volume, right? How many cubic inches could fit in this? So before we calculate it, write the number down on your paper right here. Let's take a guess. How many 1-inch cubes? Put it down. We'll see who's the closest. I'll give you 3 seconds to write a number down. 1, 2, 3. It's like you're at the circus. Pick the number of marbles in the marble deal. All right, so we're going to see who's closest. Before we go there, that's easy to know. I can visualize 1-inch cubes in that. Easier for my brain. When we're talking about a sphere, a ball, it's a little harder for my brain to wrap around, no pun intended, my brain to wrap around how 1-inch cubes, or how many cubic inches, fit in a sphere. Y'all see the difference? All these rounded surfaces, are you with me? Come on. Stay with me. Now here is a formula, a nice, neat formula, where the volume can be 4/3 times pi. Pi is a constant, 3.14. So if you know the radius of your sphere, if you know its radius, then you would know its volume. I like these kind of things. So it says use the formula to find r in terms of v, rationalize the denominator. So all that's saying is let's put r by itself. So do this with me. You might or might not know how to put r by itself. But what do you think would be the easiest first step? Somebody tell me and I'll tell you if you're right. Divide by pi is indeed the easiest first step. Divide the pi off of this side, and you would have 4/3 r to the third v over pi. Good job. What is the next easiest step? What'd you say, Easton? That is called the inverse property multiplication. Very good. That is the next easiest step. We would be 3b over 4 pi equals r to the third. We're almost, use the formula to find r. We're almost there. This problem is in this lesson because what would I need to do to get r by itself? Cube root. Cube root both sides. Now this is something we've seen already. Now we got a pi in there and a v in there. Over here, this would be r. Cube root of r to the third is r. Over here, we don't leave it like this because we don't want to leave a radical sign in our denominator. Even though, hey, guess what? Your calculator could handle that right there, couldn't it? But well, hold on. Let's go ahead just for the moment and let's write it with no radical sign in the denominator. So that tells me if I need to rewrite this, I'm going to come over here. I would go cube root of 3b over cube root 4 pi. Hey, what do we have in the denominator already? What do we got some of? What is there? What's in that denominator? Tell me. There's two things right now. A blank and a blank. What is that? And a pi. All right, so I need to be able to multiply this times the cube root of something to get rid of these radical signs. So think about the number. What number do I need to put over here? What should I use 4 times something to give me a value that it would have a cube root? No. What is 2? Very good, because 4 is already what? We have a 2 and a 2 right there already. So if you put another 2 here, you would get to 8, which does have a cube root. So we're going to do the cube root of 2 on top as well. What about the pi? How much pi do I need here? 2 of them, right? That'd be pi what? Squared. Do that on top. Pi squared. So pi times pi squared would be pi to the third. That would have a cube root of just pi. So over here, our denominator would be 2 pi. You agree? The numerator would be the cube root of 3 times 2 is 6b pi squared. There is a formula. So look at this cute formula right here. Hey, if you want to know the volume, just give me the radius. I give you the volume. But if you want to go the other way, if you want to find the radius, oh, this formula is not near as cute, is it? It's way more complicated, but we figured it out. We formulated it. We got from there to here 3 roots of 6 times the volume times pi squared all over 2 times pi will tell you the radius. Now, take your calculator. Right here it says, find the radius of a sphere with a volume of 100 cubic inches. With me? So let's type this in. I did it already. All I did was replace the volume as 100, pi squared all over 2 pi, and your calculator, you need to get what I have on my screen. When you got that, you know you typed it in correctly. I did not imagine that something that was 100 cubic inches would be a sphere whose radius was 2.8. Think about a sphere with a radius, that's like 2 3/4. How big is that sphere? Anybody? How big is a sphere whose radius is 2.8 inches? Think about right here, it's 2.8 right in about there. Someone do that times 2, so we'll know its diameter. Thank you. So that's the diameter of a ball. Hey, looks like a grapefruit. See that? Look, I'm holding it up. From here, where my finger is, to the top, is the diameter of the ball. That's the size of a ball that has 100 cubic inches in it. And so if it was hailing grapefruit size, or something else that's about that big of a ball or a sphere, it's a pretty good chunk coming down, isn't it? It's a little smaller than a cantaloupe. It's a little bigger than a softball, I think. You agree? Okay. I gotta admit, when I first saw the 100 cubic inches, I thought it would be a ball even bigger. I thought 100 cubic inches. I thought that would take a fairly large ball. What about for this? What about for this box I was showing you a moment ago? How many cubic inches did you estimate fit into this? You wrote a number down, didn't you? Okay. Take these numbers in your calculator. Remember, for a box, it's easier. It's just length times width times height, isn't it? So do this. I'll be nice, and I'll count for the wall thickness, and we'll only do the inside. 3.75 times 3.75 times 4.75. Can you believe it? Like this cute little box, you could actually, if you had 1-inch cubes, you could neatly fit 66 1-inch cubes into it. Did anybody pick close to that? Crazy. Volume is misleading. Okay. I knew I would get you on that. I'm going to stop this.